Yes, today's assignment number 8 of alkyl and aryl halides. First question, nomenclature. CH3, CH2 twice. CH2 twice or thrice will be in a straight chain. Again, CH2, CHBr, CH2Cl. This is 2 bromo, 1 chlorohexane. 2 bromo, 1 chlorohexane. Next, CH3 thrice CCl. Carbon attached to 3 methyls. Cl. This is the straight chain. 2 chloro 2 methyl propane. This is tertiary alkyl halide. Last, CH2Cl, CH2, CH, ClCl. This is 1,1,3 trichloropropane. 1,1,3 trichloropropane. Coming to fill in the blanks. First reaction is Huss-Decker-Borodine reaction, and this is a step-down reaction. Gives CH3, CH2Br. Aqueous KOH. Nucleophilic substitution reaction gives alcohol, and this alcohol with iodine NaOH. See, this is ethanol, and ethanol has required group for the preparation of chloroform, bromoform, and iodoform. So when this is reacted with iodine NaOH, gives iodoform and sodium formate. Sodium formate means sodium methanoate. Second sequence, acetylene with HCl gives chloroethene. Further reacts with HCl to give addition is according to Markovnikov rule. Aqueous NaOH gives with aqueous NaOH, both chlorine atoms will be replaced by OH groups. 2 OH on the same carbon will be unstable. It will lose water and will give ethanol as the final product. Next, this is reacted with, I missed one sequence. You probably are not looking what we are doing. This is the third sequence I've taken up. Second, I've missed out. I'll take up later. This is with iodine NaOH gives iodoform and sodium formate. I missed sequence number 2 in between. I'm taking up that. Benzene plus chloromethane, aluminum chloride. This is Friedel-Crafts alkylation gives toluene. Toluene with chlorine sunlight gives benzyl chloride. Benzyl chloride with ammonia gives benzylamine. This is Hoffman's ammonolysis. This with the chloroform KOH. This is carbylamine test gives foul smelling isocyanide. I'm writing here CH2NC. This is also obtained by the reaction of E with reverse arrow. You can see E with AgCN. So this is benzyl halide. Next, what happens? Explain why. There are 2 questions which are to be discussed. Dipole moment of chlorobenzene is less than that of chlorocyclohexane. A very important question. Chlorobenzene dipole moment of chlorobenzene is lower than the dipole moment of chlorocyclohexane. Wait a minute. Now in this case, alpha carbon atom is sp2 hybridized, and in this case, alpha carbon atom is sp3 hybridized. Now, you know, sp2 carbon is more electronegative than sp3 carbon. I'll repeat. Alpha carbon atom in chlorobenzene is sp2 hybridized. Alpha carbon atom in chlorocyclohexane is sp3 hybridized. sp2 carbon is more electronegative than sp3 carbon. Therefore, carbon chlorine bond is less polar in chlorobenzene. It is more polar in chlorocyclohexane. Second, chloroform is not used as an anesthetic agent nowadays. The reason is the reason is uh, the, uh, I told you in notes also, uh, chloroform is leads to the formation of poisonous gas phosgene. That is why this is not used as an anesthetic agent, right? Wait a minute. Yes. Next question. What happens when 2-butanol is reacted with iodine in the presence of sodium hydroxide? This is again iodoform test. 2-butanol. You can see 2-butanol has the required group for the preparation of iodoform. Therefore, this reacts with iodine NaOH and leads to formation of yellow crystalline solid, that is iodoform. You have to write a balanced chemical equation, which I think you will be able to write, but still I'll write for you. 4 iodine 6 NaOH gives CHI3. This is yellow crystalline solid plus sodium propanoate plus 5 NaI and 5 water. You should be able to write balanced equations. Chloroform is exposed to air in the presence of sunlight. This you'll find in notes also. Third, benzene diazoxide chloride is reacted with fluorobenzene and the product is heated. This is Bal-Schimmern reaction. Again, this will you find in your notes. Bal-Schimmern reaction. Distinguish between first pair, propanol and propanone. You can see propanone has the required group for the preparation of iodoform. Therefore, iodoform test can be performed. Remaining, you can write balanced chemical equation. In second case, you'll get yellow crystalline solid. In the first case, no yellow crystalline solid will be formed. Second, chloroform and carbon tetrachloride. Chloroform, carbon tetrachloride. To both the given compounds, add any primary amine, RNH2. To both the compounds, add alcoholic KOH. Heat both the test tubes. In the first case, foul-smelling isocyanide will be formed. No isocyanide will be formed in the second case. RNC plus 3 KCl and 3 water, and this has foul smell. In this case, no foul smell will be observed. Third, 1,1-dichlorobutane and 2,2-dichlorobutane. Now I'll tell you verbally, 1,1-dichlorobutane, when both these compounds are reacted with aqueous NaOH, 1,1-dichlorobutane will give butanol. 2,2-dichlorobutane will give butanone, that is 2-butanone. Now, treat both the products with iodine NaOH. With iodine NaOH, 2-butanone will give 2-butanone will give yellow crystalline solid, while 1-butanone will not. Next, 1-propanol and 2-propanol. 1-propanol, when reacted with iodine NaOH, 2-propanol will give yellow crystalline solid, while 1-propanol will not. But remember, you should be able to write balanced chemical equation. That is something very important. Next question. This conversions. 4-aminophenol into 1,4-benzene diol. Basically, we have to convert NH2 group into OH group. Convert NH2 into diazonium group. How to convert NH2 into diazonium? You know it very well. Convert diazonium into chlorine or bromine, that is Sandmeyer or Gattermann reaction. After that, react with aqueous NaOH at high temperature and pressure. This reaction similar to Dow's process. So aqueous NaOH, high temperature and pressure, this will lead to the formation of 1,2,1,4 benzene diol. Bromomethane into propanone. Bromomethane into propanone. React with sodium salt of ethyne. This will lead to the formation of propyne. Then react with excess of HX. According to Markovnikov rule, this will lead to the formation of 2,2-dihalopropane. Then react with aqueous NaOH, you'll get the final product. Acetone into vinyl chloride. Acetone has required group for the preparation of haloform. To react with chlorine NaOH, you will get chloroform. Chlorine NaOH. Heat with silver powder. In reactions of chloroform, you'll find this. This will lead to the formation of ethyne. Finally, react with HCl, you'll get vinyl chloride. Benzene into orthochlorotoluene. First reaction, Friedel-Crafts alkylation. Friedel-Crafts alkylation will lead to the formation of methyl benzene, that is toluene. CH3Cl, aluminium chloride. Then you have to attach halogen on the aromatic ring. React with chlorine in the presence of catalyst. FeCl3 or aluminium chloride can be used as catalyst. It should be cold and dark. Although you'll get a mixture of ortho and para products, but in any case, ortho is one of the products. Next question number 7. What is the difference in molecular formulas of benzene hexachloride and hexachlorobenzene? Benzene hexachloride is C6Cl6, whereas hexachlorobenzene is C6H6. No, wait a minute. I think I've told you the other way around. Benzene hexachloride is this one, and hexachlorobenzene will be this second, right? I've told the reverse way. Then what is pyrene? This you'll find in your notes.